Now, let us after a brief introduction of that complex numbers and the J operator, complex J operator. Now let us we look at that the steady state behavior of a AC circuit. So AC circuit will have resistance, inductance, and capacitance parameters. Now let us we see right now one by one what is the behavior of the pure resistive circuit, and what is the behavior of pure inductive circuit, and what is the behavior of a pure capacitive circuit. Then the combination of these three we will see. So now let us first see that a pure resistive network here. So consider a resistance R and connected to a sinusoidal voltage here, which is given by V is equal to Vm sin omega t. A sinusoidal voltage source is connected to a resistor, pure resistance here. Therefore, whatever voltage you apply here, that will appear here. Therefore, the voltage across the resistor VR, V suffix R is same as VR is same as V, since no other element is. Therefore, as whenever you connect a sinusoidal voltage to the resistance, the current is flowing here. Let us be find the expression for the current. So since the voltage is expressed as V is equal to Vm sin omega t, right, then the current will take here by using the Ohm's law. So what does our Ohm's law states here? Ohm's law is given by I is equal to V by R or V is equal to IR. So using this relation, we got I is equal to V by R. And these are, please keep it in mind, small letters. Already I told you, small letters always indicates the instantaneous values. So already V instantaneous value we have already defined here as Vm sin omega t here. Then you substitute that here in place of V. So Vm sin omega t by R. And now in this one, Vm by R is a constant. Vm is a constant, R is also a constant. So I can make that this expression into a like this. I is equal to Im by sin omega t, where Im is defined as Vm by R. Like this. Therefore, if you look at this equation 2, this is equation 2, and equation 1 here, both are looking alike. So equation 1 is V is equal to Vm sin omega t, right? And I is equal to Im sin omega t here. Only thing here it is, ఇక్కడ Vm place లో Im ఉంది. అంటే magnitude of maximum voltage and maximum currents are different. Right. Therefore, both are purely sinusoidal, we can say. Therefore, రెండిట్లోనూ కూడా there is no phase shift, and therefore they can represent that. Therefore, we can conclude what we can conclude here from equation 1 and 2. We conclude that in a pure resistive circuit, the voltage and current are in phase. ఇందుకు రెండింటికి కూడా phase shift లేదు కాబట్టి రెండు mathematical expressions చూస్తే. So both are in phase అని ఎలా చెప్పగలమంటే, let us draw a waveform here. This is a voltage waveform. V is equal to Vm sin omega t, and this is a current waveform. I is equal to Im sin omega t. Right. So this is I is equal to Im sin omega t. So therefore, there is no phase shift in both these expressions. Therefore, we say, see here, when the voltage waveform is starting at 0, current is also starting at 0, and voltage is attaining a maximum value at this point, and current is also attaining its maximum value. And once again, when voltage becomes 0 at pi, current also becomes 0 here. Therefore, we say both are in phase. Right. And when two quantities are in phase, how do we represent them in the vector? Now look at this vector diagram here. The voltage here we have taken as voltage vector as like this. Right, and the current vector is in phase, means what, both are in the same direction and the same angle, and the current vector, this is the current vector. So this is V or Vm, whatever it is. In some textbook they write, they draw for Vm, and this is I or Im here, right? So here ఎందుకు ఇవి రెండు డిఫరెంట్ గా ఉన్నాయి కదా, దీని Vm వేరు, ఈ Vm వేరు, ఇది ఎక్కువ ఇది తక్కువ, కాబట్టి అందుకే దీని లెంత్ ఎక్కువగా ఉంది చూడండి ఇక్కడ, దీని లెంత్ తక్కువగా ఉంది, రైట్. Likewise, in case of a pure resistive network, when a sinusoidal voltage is applied, the current is in phase with the sinusoidal voltage. Now instantaneous power, now let us find out the instantaneous power. In that we have an instantaneous power expression is given by power is equal to V into I. So right, instantaneous voltage into instantaneous current. What is V? V is, we have expressed as Vm sin omega t, and I is expressed as Im sin omega t. Then Vm Im, if you take here and sin omega t into sin omega t, we can write it as sin square omega t. And sin square omega t can be written as in trigonometric way 1 minus cos 2 omega t by 2. We can write it as sin square omega t. And ఈ 2ని ఇక్కడ తీసుకొచ్చేసాం, అప్పుడు Vm by 2, right, 1 minus cos 2 omega t. Therefore, దీన్ని కనుక ఎక్స్పాండ్ చేస్తే మనకి Vm by 2 and minus Vm by 2 cos 2 omega t. That is your power expression. That is instantaneous power expression has got two parts. Part 1 is this, part 2 is this. Part 1 is, if you look at carefully, part 1 is a constant power. And whereas this second part is a fluctuating power. ఎందుకు ఫ్లక్చువేటింగ్ అన్నాం? కాస్ టర్మ్, సైన్ టర్మ్ కానీ కాస్ టర్మ్ ఉంది, బట్ విత్ ఫ్రీక్వెన్సీ ఆఫ్ 2ω2. అంటే ఇక్కడేమో సప్లై వోల్టేజ్ కానీ సప్లై కరెంట్ కానీ సైన్ ω t ఉంటే ఫ్రీక్వెన్సీ, ఇక్కడ 2 times ఇట్స్ therefore పవర్ ఈస్ ట్వైస్ ది ఇన్స్టంటేనియస్ పవర్ will be twice the frequency of your instantaneous voltage and current applied in a pure resistive circuit. This is the discussion we can make. Conclusions we can. Then coming to the average power. So from the instantaneous power, we can find the average power or a one cycle by using the average quantity of any sinusoidal expression. We can find use this one. So power is equal to 1 by 2 pi integral. So average power P average, this we can call it as 1 by 2 pi integral 0 to 2 pi. V average, that is P instantaneous value. So this is P instantaneous expression, and this దీన్ని మనం ఇంటిగ్రేట్ చేసి రైట్ లిమిట్స్ సబ్స్టిట్యూట్ చేస్తే వాట్ విల్ గెట్ హియర్ ఇట్ ఈస్ Vm into Im by 2 will get it here, and this I can write it as Vm by root 2 into Im by root 2. Im by 2 ni Vm by root 2 Vm. What is Vm by root 2? Vm by root 2 is Vrms, and Im by root 2 is Irms. So we can say power, average Vp average power is equal to Vrms and IRMS values. So already I told you, capital, when you, without, even if I do not write RMS values also, if I use capital letters always represent the RMS values or maximum values. Maximum values అయితే మనం IM VM అని రాస్తాం. అది రాయలేదంటే it is an RMS value అని అర్థం. So as seen from the above, the average power is the product of RMS voltage and RMS current. The voltage and current power waveforms are purely for a purely resistor circuit are shown in here. So this is a current waveform, sorry, this is a voltage waveform, and this is a current waveform, and this is the power waveform. ఇప్పుడు చూడండి, చూస్తే మనకి పవర్ కిందాక మనకి ఎక్స్ప్రెషన్ 2 cos ω cos 2ω ఉంది కదా, అంటే వోల్టేజ్ ఆ కరెంట్ వేవ్ఫార్మ్స్ ఒక సైకిల్ కంప్లీట్ చేస్తే ఇది ఒక సైకిల్ కంప్లీట్ చేస్తే దీనికి 2 సైకిల్స్ కంప్లీట్ అయ్యాయి. సో దట్ ఈస్ ద ఫ్రీక్వెన్సీ ఈస్ డబుల్ ది ఫ్రీక్వెన్సీ ఆఫ్ వోల్టేజ్ అండ్ కరెంట్ ఇన్ కేస్ ఆఫ్ ఎ ప్యూర్ రెసిస్టివ్ సర్క్యూట్.